In this lesson, you will learn how to use the method of dimensional analysis to solve simple problems. We will be using examples involving steamships, shown in the picture here, which are large ships that carry people and cargo locally and around the world. Dimensional analysis is very powerful. Even if you know how to do some of these problems using a different way of doing math, also try to learn how to do it using dimensional analysis. Dimensional analysis is useful for very difficult problems, but also for easier ones. You can solve problems involving math, science, and engineering using it. So what is dimensional analysis anyway? It's a creative way of multiplying by the number 1. When you multiply any amount by the number 1, you get the same amount at the end. Remember that fractions equal 1 when their numerator equals their denominator. If we write a fraction where the numerator equals the denominator, it's the same as multiplying by 1. In other words, we get the same amount at the end. But why use this creative way of multiplying by 1? We use these fractions, which are called conversion factors, to change one unit into another unit. It's important to realize that units have meaning. We have to treat them the same way that we would treat numbers. For instance, a kilometer, shown at the top of the screen, is shorter than a mile, represented at the bottom by a proportionally longer line. If we look up their relationship, we find that 1.6 kilometers is equal to 1 mile. These equal amounts will be the amounts that become part of the fraction that represents the number 1. If 1.6 kilometers goes on one side of the fraction and 1 mile goes on the other side, the fraction is a creative way of writing 1 because the numerator and denominator are equal. It's also important to know that the numerator and denominator can be switched because the fraction will still equal 1. It's important to know off the top of your head or to look up this kind of equal relationships between units. These are called conversion factors. Now it's time to try it yourself. Most people know relationships of money off the top of their heads. If you don't, look some up. Which of these equalities is not true? In other words, in which option are the two sides of the equal sign not really equal? We'll pause here for you to pick an answer. 5 nickels is not equal to 1 penny because 5 pennies is equal to 1 nickel. It's important that the correct number be matched with the correct word or unit. Otherwise, the equality does not make sense. If we use this untrue conversion factor, we would not be multiplying by 1 and we would not get the right answer. Let's go back to our mile and kilometer example from earlier. It matters which amount from the equality goes on top of the fraction and which amount goes on the bottom of the fraction. Examine the unit at the start of a problem. You need to put the same unit in the denominator of the fraction. If miles is your starting unit, like here, you need to write 1 mi from the conversion factor in the denominator. The other side of the equality, 1.6 km, goes in the numerator. It's extremely important to match the units in this way. Because the fraction is written in this way, your final answer will be in kilometers. In summary, remember that the same unit as the starting amount must be in the denominator, and that unit that you want at the end must be in the numerator. Also remember that the numerator of the fraction must equal the denominator. Now it's time to try it yourself. What fraction would you use to convert dollars to quarters? We'll pause here for you to pick an answer. We would use option D. The numerator equals the denominator, and the same unit as the starting unit's in the denominator. The unit we want at the end is in the denominator. This fraction is a creative way of writing 1. Option A is upside down. Options B and C are not equalities because their numerators do not equal their denominators. Again, option D is the answer that would go in that math work. Let's look at another specific example. Imagine that a ship traveled 500 miles to its destination. We want to find out how many kilometers that is. We put 500 miles at the beginning of the math problem because we know that's the amount we want to know at the beginning. We know that 1 mile is equal to 1.6 kilometers as well. This is our conversion factor. We want kilometers at the end, so that's why kilometers is in the numerator of the conversion factor. 1 mile is in the denominator because it's equal to 1.6 kilometers, and because miles is the unit that we started with. Here's how the math works. First, we realize that the 500 miles is in the numerator of a fraction because any number is itself over 1. So we just write a fraction bar. When we multiply any fractions, we multiply across the numerator and across the denominator. It's like all parts of one big fraction. We never cross multiply, though, when doing dimensional analysis, because we can only cross multiply if there's an equal sign in the middle, and here it's a multiplication. When we divide where the fraction bar is, we get 500 times 1.6 in the numerator, and we divide by 1 in the denominator, which is inconsequential. The answer is equal to 800. Just like we always do in math, we can simplify. Remember that anything that's the same in the numerator and denominator will cancel. That's because anything divided by itself is equal to 1. Notice that mi is in the numerator and mi is in the denominator, so it cancels. Mi will not appear in the answer. Km is the only unit that remains, so our answer will be in km. Going back to our example, the ship traveled 800 kilometers, which is the same as 500 miles. Let's review the most important parts. Number 1, the starting amount, which is the amount you know, goes at the beginning of the problem. Know the ending unit, which is the unit where you want at the end of the math. You need to know the relationship between the starting unit and the ending unit. This becomes the conversion factor fraction, which is what we know is just a creative way of writing 1. That's why we can be so sure that the ending amount of our math is the same as the start. The starting unit of the denominator, the starting unit is the denominator of the fraction, and the ending unit is the numerator of the fraction. Finally, multiply across the top, multiply across the bottom, and divide, since a fraction bar is really just division. Now let's try it yourself. We'll be using dimensional analysis and trying this problem one step at a time. Pause for a moment to read the problem. Now answer the first question. "84 hours is the starting amount because it's the amount given in the problem. We don't know the amount it equals yet. Days is the question, so it's the ending unit." So the answer is A. Now the next step. What conversion factor do we use as our way to creatively multiply by 1? We'll pause here for you to pick an answer. One day equals 24 hours, so they're opposite each other on the same fraction. We put hours in the denominator because we started with hours. We have days in the numerator because we want our answer in days. In option A, the numerator is not equal to the denominator. Option D, it looks like the numerator equals the denominator, but the units are in the wrong place. Option B, the numerator is equal to the denominator, but the fraction's upside down. So we should be using option C. Now the next step. Solve the problem. The answer is that 84 hours is the same amount as 3.5 days. We did the math by multiplying across the numerator, 84 times 1, then divide by the denominator, which is 24. The answer is 3.5. Hours canceled because it was both in the numerator and in the denominator. Days is the only unit that remains. The answer is 3.5 days. Our objective in this lesson was to learn how to use dimensional analysis to solve simple problems. We just learned how to solve simple conversion problems using time and distance based on the equal relationships that we know and that we're given. Those relationships are called conversion factors.